Hello again. After going back and looking at it, I see that you guys learned how to find the determinant by doing the diagonal approach, and that's perfectly fine. I'm just going to quickly show you guys another way that you can find the determinant. You feel free to just use the way you're comfortable with, but if you do take like a linear algebra class in college in the future, you are going to learn another approach to find the determinant, and I'm just going to quickly give you a brief visual of how that works. Again, if you're comfortable with the way you've been doing it, you don't need to learn this now. I'm just going to show you that there is a different way of finding the determinant. So if you look at a 3x3 matrix, this is for a 4x4 matrix, which I'm not going to go over right now, but this is the sign chart. So in the matrix, we have a plus value, minus value, plus, minus, plus, minus, plus, minus, plus. So like it just alternates between positive and negative, positive, and then it's the same with the 4x4. Okay. So this is the approach that I showed you on that last video I did. So if you want to find the determinant of a matrix, let's take with this 3x3 matrix. Okay, so we have a plus here. So we would take this 1, so I broke it down into here. You remove the row and the column that it's in, leaving you with the 7, 3, 9, 5. Then, so you could either go to this 6 from here, or to this 2, and in this example I'm going to go with the 6, but since we have the minus here, we have to make sure that we are actually subtracting by this value, and then in this last one, it's positive again. So then we are adding the 4 with the determinant of this 2x2 matrix that we get. And I also want to make it clear that you don't have to actually start with this first entry. Just in this example, there are equally difficult, but let's say we have a, in this column, let's assume we had 0, 0, 2. You might actually want to pick to go through this column because you would get 0, 0, and you'd actually only have to find the value of this single output. So we'd have like, we would just remove this row and this column, find the determinant of this matrix times the 2. That makes sense. But in this example, they're equally difficult, so we just figured start at the 1. And then you just break these down into 2x2 matrices. And then it should be easy to find the determinant of these. So we have 7 times 5 minus 9 times 3. Excuse me. And then we multiply that by 1. Then the determinant of this one, 5 times 2 minus 8 times 3. Multiply that by 6. And then again, we're subtracting here because of this negative we have here. And then lastly, we also then add the value of 4 times the value we get from 9 times 2 minus 8 times 7. And then just quickly put that in a calculator, you get negative 60 for your determinant. Again, I'm not going to go over 4x4 matrix because I don't think you need to know it right now. But you actually take the same approach, but you're actually going to have to break it down another time. So like if we added another row and column here, it would break it down into a 3x3 matrix. And then you'd have to break that one into a 2x2. So you'd actually have multiplying by 3 different outputs. All right, I just wanted to quickly show this because to make that last video a little bit more clear. Again, the diagonal approach is fine, but it doesn't hurt to see that there are different ways to finding the determinant as well.